Alright, here we go. We've got a polynomial. We'll label it y equals p of x. We're going to look at transformations of this in regards to shifting it left, shifting it right, shifting it up, shifting it down, etc. So the very first thing we're going to look at is y equals to px plus c. Okay, and that's just going to be in regards to what c is. You're just going to shift it up or shift it down. Okay, no.
Shift it down if it's minus.
It's minus. That's it. Cool. Then we've got y equals to minus p of x. Okay, so if it's minus p of x, that means your polynomial has stayed exactly the same in magnitude, however in direction it's changed. So all that would be is if it started like this, it's going to do the exact opposite. It's going to be a flip about the x-axis, it should be, right? So it's going to look exactly the same. So I'll try to do this one as a dotted line. So can you see that?
Yep.
Something like that. Okay, so it's going to look exactly the same as this one, symmetrical in value. So I should have gone a little bit higher here because that's a little bit higher there, and then gone down. Okay, so that's y equals minus p of x, and let's pick green. What do we want? Y equals to p of minus x. Okay, y equals to p of minus x. That should be a reflection about the x's. So let me draw the original one again for a second here. Okay, so y equals to p minus x. So that means, again, my y values. Alright, how am I going to say this? So, okay, the best way is this. Alright, you see how this is my positive x value here? Right? Now, I'm going to have that exact same y value, but my x is no longer here. It must be the negative. And my negatives are no longer here. They must be at the positives. So it's a rotation about the y-axis. This is a rotation about the x-axis. And this is the y-axis. So that's how you remember. It's attached to the x, so it's opposite y. It's attached to the, you think it's attached to the y, but it's to the x. Okay. So the way it should look is, wait, let me just draw what they get, and then I'll tell you what I'm doing wrong. No, that's right. So it's like, yeah, I thought so. And did I do this one wrong? Oh, no, yeah, it's okay. All right, so it's a rotation this way. So then the way I do it, see, that's why you should. Okay, you get this, you start right there, and you do that exactly the same. So start from this y-axis and mirror it. And then start from here, mirror that.
Okay. That's
the best way. Otherwise, if I drew what they drew, trust me, it's going to look exactly like my pink one here. Can you see that? They kind of drew exactly the same. So it's not like that. Start from your y-axis and then try to redraw this to mirror it, and then start from your y-axis, mirror that as well. Okay. What else? We have this. Y is equal to px minus r. That's a shift, obviously, on the x-axis. You know that, so you're just gonna, if it's plus, yep, say it.
Go to the right.
Yeah, no, if it's plus,
And if it's minus.
yeah, if it's minus, you go to the right. If it's plus, you go to the left.
Yeah.
That's it. And then if it's just a px, it's just the magnitude, so that's not even changing its position. It just makes it larger. It makes your amplitude go larger, for example. Yeah, depending on what this a is. That's exactly right. So I think we can. Well, is that it? All right, we're done. That's polynomials covered. So what I'm going to do now, I'm going to stop that, and I will.